Welcome to the overview of BattGO technology. For those unfamiliar, it's a smart battery system introduced by ISDT. It allows certain data, including battery performance data, to be stored on a chip built into a battery and accessed by compatible devices. This technology is already available on some of ISDT latest products. In this video, I will show how the system works, what information is available to a user, and how to access the data. I will also extract a BattGO chip from a battery to find out what we're dealing with here. Before continuing, let's have a quick look at the BattGO website. BattGO is simply and broadly defined here as an information exchange system between charging equipment and discharging device. There is quite a lot of information on the website, but it's not very specific, unfortunately. However, if you scroll down to the bottom of the page, we'll find the specification and basic functions of BattGO module, which is quite useful actually. Let's have a quick look. Essentially, our system consists of a compatible battery and a device that can access data stored on a BattGO chip built into the battery. ISDT has introduced their BattGO compatible products a while ago, but there were no batteries on the market until recently. At the moment, there are two Forest batteries available from Charsun, 1300 and 1500 mAh. When it comes to the devices that can access the data stored on a battery, we can use ISDT T8 charger. There are BG8S battery checker or BG linker, which allows us to access the data on a PC. Unfortunately, the software is only Windows compatible at the moment. All three devices give us access to the same data, so there is no advantage of using one over another when it comes to BattGO technology. First, let's have a closer look at BattGO Battery. It's only slightly longer and a bit heavier than a similar product on the market. So the BattGO battery weighs 163 grams and this one 155. The extra length must cater for a BattGO chip, since the actual cells seems to have identical dimensions on both batteries. So judging by the design, it looks like the BattGO chip is built in to this side of the battery and can be accessed using this extra data wire that connects through a modified XT60 plug, which is called XT60i and was developed with AMAS. Personally, I think it's quite clever the way the extra connector is built into the XT60 plug. Right, enough talking, and let's see what kind of information the BattGO chip can actually store. When connecting an ordinary battery without a balance lead, we can only access the total voltage of the battery. When the BattGO chip is connected, we get all the additional information, including the manufacturer, the manufacturing date, the number of cells, the capacity of the battery, maximum charging rate, maximum discharging rate, number of charges, and also there are 3 alarms available at the bottom that should be triggered and saved when battery set temperature or charging discharging rate is exceeded. I'm not 100% sure what's the threshold for the temperature, but for the discharging it's 80°, and for charging is 5°. As you can see, I haven't managed to trigger any of those alarms yet. On the left hand side here, we can see the total voltage, cells voltage difference, remaining charge percentage, and also quite a cool feature, which is a battery temperature. You may be wondering how come that we can see the cell's voltage difference here. The reason for that is that a cool feature of BattGO technology is possibility to display individual cell voltages without the balance connector plugged in. However, as this feature was rather intriguing to me, I decided to test it properly and manually discharge just one cell to see what happens. Unfortunately, the BattGO readings are a bit off and not very reliable here. So as we can see, we get 392, 403, 407 and 409, and the actual cell voltages when connecting a balance lead are 391, 413, 413 and 413, so around 413 volts, and this is exactly as it should be, with one cell discharged and all the others having similar voltages. So if ISDT wants this feature to be more than just a gimmick, they should address the issue, simply because at this point it's not something I would trust and use. And just to mention, when cell voltages are similar, the readings seem to be more reliable for whatever reason. Just have a look at the other battery. It's 381, the readings from the BattGO chip. And about 379, 380 on the last cell. BattGO technology offers some additional features and settings that can be accessed by pressing and holding the middle menu button. And we can access auto storage function, storage voltage, charge current, charge voltage and exception record. Auto storage function puts a battery into self-discharging mode that will be triggered after anything from between 240 hours and 12 hours. Can obviously be switched off. After this time, the battery will start self-discharging down to the voltage set here, which can be changed from 3.8 down to 3.6. Personally, I don't think it's a very useful feature, as it will most likely take forever to discharge such a big battery using just the internal circuit. But it's here nevertheless if you want to use it. A charge current can be changed from 0.1 up to maximum charge rate, which is 5C, and for this battery is 6.5 amps. This is actually not a default charge current, so this can be easily overwritten and saved to the chip when actually charging a battery. The charge voltage, on the other hand, is a default charge voltage, and it can be set for this battery from 4.1 up to 4.2, and this value cannot be changed when charging the battery. It needs to be changed when accessing similar menu on a charger. And the exception record will show all the alarms that have been triggered on this battery. We can access and modify all the BattGO data on our PC by using this little BG linker, which is nothing more than a simple USB adapter that has an XT60i connector on one side and micro USB on the other side to connect to a PC. We'll have to install ISDT software to actually access a battery information, and as I mentioned already, it's only compatible with Windows at the moment. So let's move to a PC and see how it works. First, we have to download the software. So we need to go to ISDT website, which is isdt.co. Go to download section. Scroll down to Application, Software and Driver and click on BG Linker PC Software. As we can see in the right corner here, it's being downloaded. Now we go to the download folder, unzip our software, go to the BattGO linker folder, double click, okay, and it's as simple as that. Okay, now we have to connect our USB adapter, the BG linker. At this point your PC may install some drivers which are fairly standard, so you probably don't have to download anything. And now we're ready to connect the battery. And that's it. This is your PC software that gives you all the information I've mentioned already. So in the top section we have all the data that cannot be changed and it's written to the chip. And in the bottom section are user preferences that can actually be modified. So we can change the full charge voltage, we can change the storage voltage, we can change default charging current. As I mentioned, this is not the default charging current, it's the last setting that was used when charging a battery. So as soon as we connect the battery to a charger, change this value, the new value will be written here. And this is automatic storage timing, which can be switched on and changed or kept off. In the left hand side corner we can access our alarms that have been triggered, and this menu is called abnormal cycle records here, and it was called exception record on our battery checker. And in the bottom left hand corner we can change the language here. To be honest, I was a little bit disappointed with the amount of data available through the PC software, as I was hoping to get access to additional information here. But unfortunately, there isn't any more data stored on the BattGO chip at the moment. So this is all we can access. And these are all the features of the BattGO technology and all the battery data available to a user. We can access all of that using a compatible device, which is quite cool, isn't it? However, there is a little bit more to that. What I mean is that we can actually use BattGO Data to add functionality to the devices. How this data is used depends on the manufacturer's implementation, but I will quickly demonstrate this on the ISDT T8 charger. The T8 has BattGO compatibility both on the input and output. There is a T6 Lite charger listed on ISDT website, and that one only supports BattGO on the output, for example. I have BattGO compatible batteries plugged in on both input and output. However, they are not fully plugged in, so the extra pin is not connected and we cannot access BattGO Data at the moment. As you can see, we can only access basic info regarding the input battery, and there is no information regarding the output battery at all. So if I plug in the input battery, we can access all the BattGO data, which I already explained to you. And if we plug in the output battery properly, even without the balance lead, we can get access to BattGO data from the output battery. How do we tell the difference which one's which? If you have a look on the top here, there's a little logo with the arrow pointing up or out, which indicates the output battery, and the little logo with the arrow pointing in is the input battery. So this is output. Also, our working info contains the information regarding the range of voltages for the individual cells here, which wasn't available before. And we also can access individual cell voltages on the output battery here. But this is the battery information that is stored on BattGO chips on those batteries. But what I want to show you is the extra functionality that BattGO technology adds to the charger. So let me show you first what happens if we gonna use a battery without a BattGO chip. If you go to the settings, we can change maximum input power here, and we can change minimum voltage. As soon as we plug in the BattGO battery and go to the same menu, we cannot change the maximum input power and we cannot change minimum input voltage. The reason for that is that the maximum input power will be connected to the maximum output power of the battery. So we cannot exceed that value anymore. And in terms of minimum input voltage, if we start charging the battery now, we can see that we have input limit here, which changes to 3.3 volts per cell. So we can specify if we want to limit that to 3.3 volts per cell or 3.75 volts per cell. So when it comes to the added functionality on the battery that is being charged, again, let me just show you what happens if we don't have this plugged in. As you can see, we can change the cell's voltage here, we can change the cell count, the current, and input limit is related to the input battery. When I access a BattGO chip on my output battery, I won't be able to change any values related to the battery itself, which means I cannot change the voltage or number of cells of the battery. I can change the current obviously here, but that's about it. If I want to change the voltage, I will have to go to the BattGO menu and change it there, exactly as I mentioned to you before. So how do you access the BattGO menu on this charger? Again, you press and hold the menu button, and at the bottom of the page we have the menu for the input battery, and it's exactly the same as before. And we also have a menu for the output battery here, which looks exactly the same, it just refers to a different battery. And that's it. You can think that it's not much, but it actually makes the whole charging process a little bit easier and helps to avoid mistakes when charging your LiPos. So now let's quickly open one of the batteries and have a look what's inside and what the BattGO chip actually looks like. Okay, let's have a closer look. So we can see the main chip is on top of a larger PCB that has all the individual cells connected to it. It's quite a compact and clever design. It doesn't take much space. There's obviously data cable connected there as well. And that's pretty much it. So now we know what we're dealing with here, and we can move on and have some final thoughts regarding the BattGO technology. Even though this is quite a young technology, it works rather well actually. Of course, there are a few little issues that still need to be ironed out, like for example inaccurate cell voltage readings, or the fact that I was never able to trigger overcharging alarm even though I charged both batteries using 10 amps a few times, and this is well over 5C, which is a maximum charging rate for both of the batteries. Yes, I know it's not recommended to charge batteries like that, but I did it for the science, so it's okay. Also, even though the batteries seem to perform quite well, I don't think they will ever be able to reach ATC output, which means that over discharging alarm most likely will never be triggered either. I would prefer if BattGO chip could save maximum charging and discharging current that occurred on the battery and offered access to a few last readings, I don't know, 5 or 10 or maybe even more. At the moment, both battery overcharging and over-discharging alarms are not very useful to me, I'm afraid. And this is all I wanted to talk about when it comes to BattGO technology. I really like the functionality it offers, but I'm not sure if this is something that will become popular and whether it will catch on. I'm sure this mainly depends on how many LiPo manufacturers join BattGO revolution. At the moment, it's more of a novelty and proof of concept to me, but I definitely like the fact that ISDT is trying to innovate the market and introduce new ideas. I hope you enjoyed this video. I'm really interested to find out what you think about the technology. So if you have any comments, please post below or join the discussion at RC Group's forums. Thank you for watching.